Hi everyone, my name is Ezekiel, here with UCSB Physics Circus, here to explore an experiment as to how lunar craters form on the moon. So if you take a look on a clear night, sometimes you'll be able to see these impacts, also known as craters, and the lines that extend from them, or the ejecta rays. And using these easy to find materials at home, we'll soon find out that these are a result of asteroids or small or large rocks that are roaming throughout space that then collide with the moon, which as a result forms these craters and the ejecta ray.
So first, you would like to get a cake pan or tin, preferably. Next would be the flour, the cake sprinkles, the cocoa, a spoon or a shifter, whatever comes more useful, towel, newspaper or paper towel, and about 2 to 3 different sized spherical objects, whether that be a small rubber ball, rocks, or so forth. But in this case, for my purposes, I'll be using coins to emulate that as well. So as for this first step, you will want to prepare the moon quote-unquote subsurface. So spread about an inch of flour into your cake pan. The flour will represent the parts of the moon's crust that an impactor will pulverize and blast out. Second step would be to add the rocks and minerals. So add a layer of cake sprinkles to represent rocks and minerals buried under the surface. Third step is to create the moon surface. Add a thin layer by sprinkling cocoa over the top with a spoon. You can also use a sifter for even coating. The cocoa will represent the surface layer on the moon. As for the fourth step, prepare for impact. So now find a spot where you can safely and easily drop or safely throw some ball of mass into your cake pan. You may want to put down a newspaper or a towel to catch any baking ingredients that come out of the pan as well. Fifth step is to make a moon crater. Now simulate a rock impacting the moon by holding a small rock, for example, above your head and dropping it into the cake pan. Observe the ejecta pattern created by the impact, and if so, did any of the sprinkles get ejected out of the crater? And as for the last step, time to experiment. Try dropping different sizes of balls of masses from different angles, heights, and speeds if you can. Now how does this affect the ejecta pattern differ from one impact to the next? Throughout this at-home experiment, you will take your first steps as a scientist, but most importantly, as an experimentalist. You will experience how changing certain things at the beginning of your experiment will impact the overall outcome of your experiment, or how, no matter how many attempts you make, there will always be some factor of uncertainty with your measurements. This will surely prepare you for the larger world of experimentalism as you venture throughout your career as a young scientist. Furthermore, this experiment will serve as an early introduction to concepts such as energy, whether that be kinetic or potential, collisions, whether that be elastic or inelastic, or conservative central forces such as gravitational attraction or electromagnetism, all prevalent explicitly or implicitly in this at-home experiment. And albeit it may be years till you finally fully explore these concepts in depth, you can check out additional demonstrations and at-home experiments through the UCSB Physics Circus website that talk about all of the aforementioned concepts such as elastic and inelastic collisions and so forth.